by the click this wave pattern, best parameter, first profile here, this speed, you can compare both of them as certain stage of modified respectively. And this is sensitivity result. For example, as I mentioned earlier, we changed parameter, the SAC curve and bulb area UV shade and the angle bulb height. For example, for KC, as this model KC, these two parameters is most sensitive to the result. Okay. Increase of angle, so this is original, and this angle is reduced. Okay, wave rating is not so good. So this way is the best. So we can understand, we can study what kind of more parameters can affect the final result. Okay, so this is very good for specific study. Actually, so this is the result compared to pressure and wave contour and wave profile along actually. Conclusion. So we developed a design of Brand-Bigglesform parameterization program coupled with a local and global construction algorithm. So we follow naval architect design practice. So this is very cost effective. At least 4 or 5 hours later you can design and see the result. Thank you very much for your attention.
Thank you, Professor, for your nice lecture.
I request our chairman to hand our souvenirs over to Professor June for his nice presentation and this occasion and for his contribution to our performance.
We have almost made it. I don't think we can take many questions from you, but since we have still some 5-6 minutes, probably we can take some 2 questions. There are 2 types of lectures. So, the second and third one by Akinoto and Professor John underlying the CFD. So we'll take 1 question for those two. If you have one, please. Yes.
Thank you. Interesting presentation. Well, as you limited, so one question for one speaker. The first, could you introduce about 20 components? So I want to know what's the most serious component out of the 20 components. The second, you mentioned the increase, total drag increase. I want to know the proportion of the hull and rudder, the proportion of the drag, what's the percentage of the hull and what is the percentage of the rudder. And the third, you said that your result compared with the experiment, you said that agree with the experiment, but I want to know which speed, because you mentioned about container. Usually container speed is higher, and then in which speed you compare between your result and the experiment? Thank you.
Are your questions for Dr. Akimoto? One for Professor Meswai.
Thank you for your question. A very quick answer to the question is which one is more important than the other. I can't answer that. It depends who is looking at it. If you are the ship owner, you would like it to be the cheapest operationally and from a capital cost point of view. If you are the IMO representative, you want it to be compliance with the IMO regulations. If you are the shipyard, you would like it to be easy to fit and not to change your schedule so much. So it depends who is looking at your circle. So the best solution is the one that you arrive at a compromise between all of them.
Your question is on the interactions between proper action and rudder. Hull and rudder. Actually, at present, we do not include the flow around the rudder in the simulation. Only rudder is modeled as a mechanical model. Rudder action is modeled as a three-dimensional finite span wing. It is a present situation. I have to improve the structure of the simulation to accurately include the interaction between hull and rudder action. Thank you. Thank you for your question.
Your question is what speed is used for comparison experiment? Design speed, full number is 0.26. Design speed, at the design speed, whose full number is 0.26.
I mean, actual, not, yeah.
Actual speed.
Yeah.
I think that's 24 now. You can calculate. Whose length is 340. I think around 24 or something like that.
We can take one more question if you have, please.
I'm asking the last speaker, I could imagine the first queue. How do you
look at your present optimization in terms of global the climate change criteria now setting for coming to how do you bring that conditions into the climate, these optimization techniques?
Certainly, if we reduce the resistance, we can contribute the CO2 emission. So, if looking at the Korean shipyard or even in Japanese shipyard, release their target CO2 emission, the decrease in terms of year, for example, 5 years, 10 years, something like that. Among them, we make a whole form optimization contribute around 1%, something like that.
I mean, that's very obvious. You increase decrease the resistance, you reduce the power, obviously you reduce the emission. But what are the other angles you're talking about? Say, if I tell you that we all design ships with nuclear power, we have zero emission.
As I mentioned, if looking at the Hyundai, Samsung, they were given the Mitsubishi, they released their target. There are several ways there. For example, sustain wind power or solar energy, or even the heat recovery system or energy power. So depending on that, the amount of CO2 reduction is stated. But I cannot remember the percentage total. Maybe for the Samsung cases, 2 or 3 in 10 years time, the CO2 reduction is more than 50% can be achieved. They released recently. Okay? So there are several components there. So this is one of them.
Okay, thank you.
Okay, we then come to the end of the session. We have seen 3 papers, very interesting and valuable, of 2 different kinds. The papers by Dr. Akimoto and Professor Chun underlying the CFD process, and that will generate interest not only in naval architecture but also in civil engineering and mechanical engineering as well, because CFD or finite difference sort of things are also being interested in the quarters of mechanical engineers as well. And the papers presented by Professor Misbari is a paper of different taste. I have enjoyed it very much, and I'm sure all of you enjoyed all these 3 papers. And so let us give a big hand for all these. We have the arrangement for tea outside this hall, so please participate. Thank you very much.
Correspond, Erhanas and Nazreen. On the paper number 102, effect of diameter of heated block on MSG free convection flow in a cavity. Just start, please.
Good morning, everybody. This is Salma Parveen, Assistant Professor, Department of Mathematics, BUET. The title of my work is Effect of Diameter of Heated Block on MSG free convection flow in a cavity. Introduction. Natural convection in a cavity with obstacle has many engineering applications such as solar collector, thermal design of building, air conditioning, cooling of electronic devices, etc. Finite element analysis is a method to solve numerically partial differential equations.